I am from the representative of Group 1 Robotic Arc Welding will present our assignment. Without wasting time, let me introduce the group members. Let's go. The development of automated welding solution continue to be driven by the need for highest product quality, productivity, and cost reduction. In addition, the flexibility of a good manufacturing system, which is important to respond to the dynamic behavior of the market, and therefore maintain a competitive product, has been a key development target for the manufacturing industry. As a result, robotic welding processes offer an alternative solution to traditional manual operation and hard automation.
Assalamualaikum. Today, I want to present about the introduction and three similar system does not use IoT. Introduction. General overview about the system. Robot welding means welding that is performed and controlled by robotic equipment. In general, equipment for automatic arc welding is designed differently from that used for manual arc welding. Automatic arc welding normally involves iron dirty circuit, and the welding equipment must be able to operate under those conditions. In addition, the equipment components must have the necessary feature and control to interface with the main control system. Justification on why the system need to be integrated with IoT. The concept of the Internet of Things IoT begin with object identity communication device. The device can be tracked, controlled or monitored using a remote computer connected via the Internet. Internet of Things has different definition. In a nutshell, it is defined as a thing present in the physical world or in the environment attached with sensor or with any embedded system and connected to a network through a wire or wireless connection. Next, three similar systems that does not use IoT. First, sheet metal arc welding. Second, gas metal arc welding. And lastly, gas tungsten arc welding.
System overview have two parts. First, the component involved have voltmeter with dual terminal, wire feeder, manipulator, vision computer, and second part, the software involved Arduino Uno and Proteus. This overall system flowchart for robotic welding. First, turn on machine and all components. Open valve gas, setting voltage, current digital welding machine, and put sample for welding. After that, using direction sensor for sample size, area for welding. If everything is finished, we can start the process. This sample portier for IoT system based on figure have Arduino board connecting to manipulator robotic welding, voltmeter, vision computer, and digital welding machine.
So now I will present for my part, that is processes and activities offered by the proposed systems. So welding operation involve the use of gas sensors, direction sensors, and laser sensors. in response to the robotic welding system, the sensor will then communicate with the Arduino and carry out the welding stage. After being sent, the Arduino will evaluate and interpret the signal that was collected from the sensor. Every signal and bit of data will be carefully checked by the Arduino system because it will be the source of information received by the welding robot system. The welding robot receives data that the Arduino has thoroughly processed. Meanwhile, the monitor system allows the user to receive information, and this will alert the user if an error has occurred on the monitor. Then the display will therefore indicate if the user has received any message or not. The Arduino will also send data to the welding robot system. The chosen sensor system will determine how the welding robot will be functions. This is done to guarantee that the area or distance that needs to be welded, the welding speed, and the production of enough gas are all perfect. Okay, so now we will go to the purpose design. So this is the purpose design. As we can see, there is 3 sensors included. There is gas sensor, direction sensor, and the laser sensor. So then, all of these 3 sensors will be sent to the Arduino Uno, and then the programming will be done, and then the Arduino Uno will be send information to the robotic arm, to the torch, to the welding features, and the electronic control. So then, the welding can be done with the RoboticArcWelding. Thank you. So as we can see, this is how the RoboticArcWelding will be done. So I hope you can enjoy this video.
Hi, my name is Darren, and I'm going to talk about the significance of the proposed system. The advantage of the system is it is able to capture data offers insight into efficiencies and inefficiencies in the welding process. This forms the basic for procedural improvement that can maximize the performance of welding machines in order to improve welding productivity and weld quality. The next one is business opportunity to market the system. Robotic welding has grown essential in metal and heavy sectors, particularly in the automobile industry, which uses spot and laser welding due to its time-saving advantage and high output. It is useful for short welds with curvatures and repetitive, consistent action that don't necessitate periodic welding process, adjustment, and alterations. The robot may also be used for long welding, such as in shipyard sector, thanks to the additional dimension. Despite robotic welding being most commonly utilized in mass manufacturing, where productivity and volume are critical, programs may be tailored to meet any requirement, and robots can be used for shorter and even one-off manufacturing while remaining cost-effective. Next one is the target user and customer. Market indicators that segment by kind, such as arc welding, spot welding, and others, are the most targeted users and clients. In addition, we aim to reach the end users of this technology in the fields of aerospace and defense, metal and machinery, electrical and electronics, and automotive and transportation. As for the conclusion, different industries have benefited from complementing the Internet of Things in welding processes. IoT may help in increasing productivity by closely monitoring different parameters involved in welding materials. Sensors are usually used to gather data that are then analyzed to improve processes. Automating the welding process has also decreased labor costs while increasing productivity and output. This has also helped companies to be flexible in producing similar products by making adjustments through the system. Lastly, integrating the internet into production has made working remotely possible.